This video is about grammars and derivations. So it's about grammars and derivations. In this video we introduce the concept of a grammar, and we'll do this using an example. And the example are arithmetic expressions of binary numbers. Typical expression might be something like this: 1, 1 plus 1, 0 times 1, 1, for example. And I will give a grammar that can actually produce all the valid regular expressions. And the grammar is as follows. Grammars are essentially or consist essentially of substitution rules. So we can substitute a left-hand side by a right-hand side, and let's say we start with the symbol E for expression, and we say, an expression can be an expression plus an expression. Or alternatively, it can be an expression times an expression. Or we are allowed to put parentheses around an expression. Or alternatively, it can be a binary number. And now, this is of course a recursive substitution rule, and now we have to define what's a binary number. A binary number might be something that starts with a 1 and the rest is a binary number. Or it starts with 0 and the rest is a binary number. Or it's simply 1 or simply 0. And now I claim that it's possible to derive such arithmetic expression, as in our example here, by using these substitution rules. And I'll start here. You'll see it's a lengthy process. So we start with the expression with the start symbol and say, okay, the outermost operation is multiplication, so we substitute this E by E times E, using this rule, so it's E times E. The left part, this one here, will become the parenthesis, so we substitute this E by E in parenthesis and keep the rest. Then we go on. Here we have the plus sign, so we will need this rule here, and we replace this E in the middle by E plus E. So we derive E plus E times E. And now we start deriving the individual numbers. So we change this E using this rule here and get a B plus E. And the rest stays the same. And with this B, we apply this rule here because the first character is 1. So we replace this B by 1B using this rule, and we continue. And then we replace this B using this rule here by another 1. So we get 1, 1 plus E times E. And so on. You see how it works, I hope. And in the end, we'll end up with the expression that we would like to construct, and this one, 1, 1 plus 1, 0 times 1, 1. This is actually called a derivation. So we start with the start symbol and we derive the word we would like to have. These rules here are substitution rules. The idea being that we always substitute the left-hand side with the right-hand side. This here are alternatives. So it's just a shorthand notation for alternatives. So we can choose to substitute this E either by E plus E, or by E times E, or by E in parentheses, or by the B. So that's for alternatives. This is the substitution rule, and the substitution rule is often called production. So this is a production. The uppercase letters, they are kind of variables, and they have a special name. They are called non-terminals or variables. Non-terminals or variables. The idea is that as long as we have non-terminals in our form, in our sentential form, then we have to go on to apply the production rules, the substitution rules. The 1 and the 0, they are called terminals. They are just the letters from our alphabet. So letters from the alphabet. And there must be one special symbol, one special non-terminal that we use to start each derivation, and that's the so-called start symbol. And in this case here it's E. So there must be one start symbol. Okay, so that's the general idea, and now we are ready to give a formal definition of a grammar, and we just take all the things we have found here and put them together in one four-tuple. So a grammar is G. It is a set of non-terminals, an alphabet, sigma, a set of production rules, and a start symbol. So we have N as a set of non-terminals, we have sigma, the alphabet of terminals, we have P, set of production rules, productions, and S, start symbol. After we have defined what a grammar is, grammar being this four-tuple, we have to define what a derivation is. And the idea with a derivation is that if we have a so-called sentential form, so some string over the terminals and the non-terminals, something like alpha 1, alpha, alpha 2, then we can derive from this string a string alpha 1 beta alpha 2, just if we have a production rule that replaces alpha by beta. So we just keep the surroundings of the alpha, we keep it, and we just replace this alpha by this beta. So it's the idea of the substitution rule. That's what we have done here in our example. We've always replaced, for example here we have replaced this E by the E in parentheses, according to one of the substitution rules. And we'll use a notation with a star for the so-called reflexive transitive closure, and we'll write that we can make a derivation from alpha to beta, and this is the so-called reflexive transitive closure, and this means in 0 or more steps. So if we do 0 or more of these derivation steps, then we have such a possible derivation in the reflexive transitive closure. That's the idea. And having defined this, we can define what the language of a grammar is. That's generated by a grammar, and that's simply the set of all words, W, taken from sigma star, so the words that only consist of letters from the terminal alphabet, such that they can be derived in 0 or more steps from the start symbol. And that's actually the language that's defined by a grammar.